Hope you are fine. Welcome back to another session. In previous week we explained logical functions. We explained how we're going to write an if function alone if there is one logics. It's explained on the table. We said that mainly we focused on two outputs. All our calculation or the things that we done it, if you had two output, only one if function required, then the conditions that we have it, if it's just one logical you have it, we said no need for and or, but if you have two or more logical, we should have used and or function. Now those cases, they're very simple. Two output means that whether you do that or the other side, so there is no third option there. Now unfortunately the things that we're doing it, sometimes we'll be having more than two options to choose. Now when you're trying to calculate settlement of a building, let's say you have a building and you want to see that under the load is there, how much is it going to settle. Now the equation for settlement will be distributed in three categories. So according to each of those, you're going to choose one of the categories in order to use it for the calculation. Let's say I'm talking about primary consolidation or primary settlement there. Some of you don't know what I'm talking about, but just imagine that you have a building and there is a load. The load is affecting the building. You have some soil properties and you want to know how much is going to move into the soil or how much this building is settling down. They call them settlement. Let's say for example this is compressing the soil, it comes down, and an easy way to understand. Now in that condition we have three equations to be used. Which one you're going to choose depends on the condition. Now when I say three equations, it means that there's three probabilities. I mean there are three options for me to choose. So it's not just two options to say okay whether this or the other one. Now this is we call outputs. When I mean outputs, basically when I created this table, output means that depending on the if function, you can choose two functions there. Now if you have three or more, you need more than one if function. We call this one nested if. Now new update of Excel, I believe, I'm not sure if it's 2016 they have it, but in 2019 I've seen that they add something which I may explain it. It's not in the lecture note. They call ifs. It's not in 2019 they made it much easier because of this nested function. So for those who are going to have new version of 2019, for example this I have it on my computer is 2016, I don't have it ifs. Now the same way we said some ifs, they add ifs, they made it life much easier. It has different way of working, but unfortunately it's not from the 2016-13 version. They don't have it. The new version 2019, which is out, some people can purchase it or download it. In that one there's ifs that can solve the problem easier. But it does not mean that if you don't know, if you don't have ifs you cannot solve the problem. No, that's why we're going to use nested if. Now nested if means that you're putting if inside if to solve some problem. Now the way to think of it is by in the previous session we said if else. If else. Now there is only one if and there was else there, but this time when we're talking about nested if, we talk about if else. So you can have as much as if else you have it, and there will be the last will be else. Now this is the normal conditions. If like this, if else will be like this, go do this one, if else. So always if else till the last one will be else. Now this is, we call it nested if in Excel. I mean nested means that if inside if, we call nested if. Now remember the logic does not depend, like the if function, the number of if function does not depend on the logic. The logic, it's basically for who? For the and or function. Now chapter, which is lecture note 9, it is mainly focusing on 3 or more output, 1 logic. This is chapter 9, or lecture note, you call it 9, and 10 it's only for nested if with and or. Remember, the first one is the easiest one. If, remember, if we said that there is if, a parenthesis, there is logic, then you put a separator with a comma or semicolon, I don't know, then true value will come. I mean, if this is true, it's going to come here. If not, it's going to go here. So we called the first one logic. We said this is going to be, this is the logic, we have it here. This is the logic. And we said that this is if it is true, it's going to come here. If the logic true, is going to come here. If false, is going to come here. We said in this part, if you want to write logic, we said that if you have multi-logics, you have to use and or. This is the main structure of if function. Now, when we say nested if, what we will do, remember this, we're going to change one of them, whether this one or this one, to another if. Now this is value, yes, we call this one this value if true. I mean, this is if, just write it like not if, not to confuse you. If this logic is true, I'm gonna come here. If the logic is false, I'm gonna come here. When I said I'm gonna come here, we will do a calculation, something, as we did it in the previous example. I told you to watch the videos. If you haven't watched the previous videos, please do not continue. Go back to the other videos in order to understand the basics of if function, how we're using logics, how we're using and or, then you will understand this one. Now, nested if means that we're going to change whether this one or this one to another if. So that we call if inside if. If I put another if here with a plus between them, this is not nested. This is two if, but just there is a summation between them. It's not nested. Nested means that you're changing one of those two, the value of true or value of false, to another if, and that if will have two values inside it. That's why it will be a bit confusing in order to work with nested if. Now let's say the condition that we have it here. Now let's talk about this one before going further. Now, how many if I supposed to input inside each other? Now we said that one if can have two output. But when you say nested, I'm going to remove one of the, I'm going to substitute one of the outputs by another if. So the number of if function that requires to solve a problem depends on the output. So the easiest way to know how many if function required to solve the problem is like this. Number of if function needed is equal to number of outputs minus 1. This is valid for the first one even. Look, 2 minus 1, 1 if function. I'm not saying logic because this does not if function does not depend on the number of if function does not depend on the logic. It depends on the outputs. 2 minus 1, I need 1 if function. Now for the first one, look, y is equal to x squared root x 5. If x is smaller than 0, x greater than 0 is equal to 5 is this. Now I have 3 conditions here. I mean 3 conditions, 3 options I have it here. 3 options. Now 3 outputs. We need 2 if function because 3 minus 1 is going to be 2 if function can solve this problem for me. Why? Because if you understood in the beginning, we said that we're going to call this one if, we're going to call the second one if else. I mean, let's say if, this is going to be else. Now the else does not need, you can solve it with 3 if, by the way, but minimum 2 if required. This is what we call it, minimum 2 if required. If you say number of if function needed, you can call this one minimum number, because I told you in the previous session that if I brought an exam, sometimes student, many years that we asking question like some student, if it was solvable by 6 if function, they solve it by 10, 15 if functions. It's okay, but you have to know what you're doing. So if you make it shorter, if you're good at the functions, the logics, you can make it shorter. If not, go for the long way. I'm going to explain both ones, whether to understand and whether you use which one, it's up to you. At the end, if it's working perfectly, that's what we want. Now, this is an if, else. Now look at here, 1, 2, 3, 4, y is equal to x plus 5, x plus 6, x plus 7, or not defined. Not defined is another case. That means that in like x is equal to 50 will be like this, 60 will be like this, 70 you have to use this one, else will be this. Just a simple example. For output, just idea. For output means we need 3 if function to solve it. Now, I try to make this one as easy as I can in the lecture notes to see the possibilities of nested if. Now, we have 3 possibilities of nested if. Now, we said that, let's just have a look. When I look at an if, there is a logical test, there is value if true. Now, this one, what we did, we changed the value if true, value false, to another if. Please look at it. This is a 3-part. Yes, the green one is for what? For the first if. This is the first if. Each if supposed to has 3 arguments. Each if supposed to has 3 arguments. Logical test, value if true, and this is going to be value false for the big if. Now, when you open another if, checking that if inside, I must have 3 more arguments. Logical test, value if true, value if false. Now, this is how does it look like in the flowchart. It looks like this. You have an if function. If it is true, it's gonna come here. It's gonna come here. If it is false, look, if it's false, you're going to put another if. That's what does it means. Like if this is true, it's gonna come here. Yes, this is true. This is true, is gonna come here. But if it is false, it's going to here. And this one, it's gonna control again. It says, okay, wait. Well, the first condition was not true, it was false. You came here, but now I have my conditions. If you pass my condition, I'm sending you here. If not, I will send you here. So again, there will be a control, a checkpoint. That checkpoint again will say that, okay, if the logic is true, I will send you here. If the logic is not true, I'm gonna send you here. That's how does it look like in the flowchart. When I say if, there is a logic. Remember, if there is a logic. If the logic is true, it's gonna come here. If the logic is false, it's gonna come here. Now again, since it's false, I'm gonna apply another condition. If this condition in the second if, look, it cannot be the same as it can be the same, but normally we're using different logics here because we're going to define something else. If it is true, it's gonna come here. If it is false, it's gonna go here. Now those are the outputs. Those are the outputs. Now how many outputs I have it? 3 outputs here. I use 2 ifs, then maximum output I can get will be 3. Now this is an example here. We will solve those examples. We're gonna solve those examples. Now I may have different condition. Why? Instead of converting the value if false, I can change the value if true. Remember, the logic, it's the one that deciding what you do. I said in the beginning, if function, the logic is it's very important. So if this logic is true, if it is true, I will give an if function. If it is false, I have a calculation. So if it is true, I'm gonna again apply another if function, and that if again has 3 arguments. 1 logical test, value if true, value false. Looking out that the big if as well, 1, 2, 3 argument, 1, 2, 3 argument. Each if they have 3 argument, and this is basically will look like something like this. Instead of changing the false, you're gonna change the true one. It's the same as the top one, but instead of changing the false one, look, if this if was not here, it will be false here, yes, but I changed the false to another if. I believe you remember. Do I have it there? Let me see. I have the if function, which was the previous one. I don't know if I did any flowchart there. No, we didn't do any flowchart there. These two I believe in the video I explained the flowchart in the videos to see how we said that an if function will be having a true or false. So we're changing the false here to another if. That if will be having in true false there. Now instead of changing the false value, I can change the true value. But remember what will happen, the if functions comes, or the second if comes instead of value of true. The third possibility that I have it, I will put two if inside one if. Now I will be using three ifs here. By the way, we'll use the combination of all of them together. But this is, I can still change the two outputs to two if. Now look at here, we will look like this. The first if does not have a direct output. I'll say if something true, I have another if. And that if will be having the output. If something is true, again I have two output, then I will be having two more output. Look, three if function, four outputs. The rule says that number of outputs minus 1 will be equal to number of if functions. Or you can say number of if function plus 1 is going to be number of outputs. Now let's look at this one with some mathematical functions to be easy to understand. Why it says that if x smaller than 0, that's going to be y. But it says that if x is greater or equal to 0, now you have to check for z. Look, after this if, I have another condition. So I'll say if x smaller than 0. Look, I can say x smaller than 0. If this is true, this will be x squared. This will be x squared. Why? Because x is smaller than 0, y will be x squared. But if x is not smaller than 0, remember, we say we don't need to change the tail of that one. If x is not smaller than 0, it means it's greater than 0, so I don't need to check this one again. Remember, this is already in here. If this is true, the false contain x greater equal to 0. Remember this, please. You don't need to check this one because this is the tail of this one. It means if a value is not smaller than 0, sure, if it will be greater or equal to 0. So it will already come here. No need to check this one. Now, but you realize that now I have two options, and that option depends on another if. If z smaller than 0, I come here. If z greater than or equal to 0, I come here. So this one, again, those are tailing of each other. This is the tail of this one, or this is the tail of this one. I can use this one, or I can use this one. So if I use this, I'm not going to use the second one. Why? Because if z value is not smaller than z, sure it will be greater or equal to 0. So if I use here z, I'm going to check for z this time. So if z is, let's say, greater or equal to 0, I'm using it. Now which one I used? I used this one. Look, I used the first one. I didn't need the second one. This time I use this one, z greater than or equal to 0. I don't need the smaller than 0. Why? Because if this is true, yeah, I know what I'm doing. True, it's going to be root x, for here will be root x plus root z. But if z is not greater or equal to 0, it means that, or another way that to say that it is false, the false already contain a value of z which is smaller than 0. No need to check this one. We're not going to put this one inside the, look, this one is not inside the if function. This is not inside the if function. This is not inside the if function. Yeah, this is inside the if function. Look, only the one that comes with the if, will be within the first if, this will be within the second if. So if it is false, in the case of false, there will be x squared plus z squared. Sorry, root x plus z squared. Now, so bring this one down here. This was x squared. Now, remember, you could use different way to solve it. Change the logics, the location is going to change. Like if I would have choose x to be greater or equal to 0, the if was going to come here. I can solve the first example by using the second algorithm. By using the second algorithm, I can still solve it. I mean, I can solve the first example by this one. Well, I'm just changing the logics, changing the logics. Look at this example. It says what? If x is smaller than 0, I have two more logic. So if I say if, look, if x is smaller than 0. Now if this is true, I don't have direct output, I have another if. So that's why I'm changing the true this time to another if. I'm saying if x smaller than 0, z smaller than 0. Now if z smaller than 0, I mean x smaller than 0, z smaller than 0, this will be x squared plus z squared. Remember, the tail of the if, the logic, no need to be used. That's it. Use two logic and that's it. Now if z is not smaller than 0, we know that z will be greater than 0. Still I am inside here. Remember, this is the problem, like with the student, like confusing, that you must understand that you're still inside this if. You have to finish this if, then you will go back to the second if. Why? Because I still haven't finished the false value. Always we write the true value first, then we'll go to false value. Remember this, please. The first thing you write if, then the logic, then you go to value of true. Now I have started with another if, then I will write the if, the logic, then I will go to value of true, then I will go to value false, then I will go to the value of false for the first if. This is the step. So if z is not smaller than 0 means z is equal to 0, no need to check this one because it's the tail of the first one. Then directly I will write here x squared plus root z. Then this is gonna finish. I haven't finished the first one. Why? Because this is only the true value. What if x is not smaller than 0? It means x greater than 0. If x is greater than 0, this will be the function root x. I don't need to write this one again. Why? Because it is the tail of the first one. I already wrote x smaller than 0, so x greater than 0 will be part of the false value. I need you to understand these things. False value will contain, when we say false value already contain a logic inside itself. No need to put another if, another logic for it. You can put another if, but it will be longer. Now let's say we have this condition. This condition, if x is smaller than 0, bigger than 0, I have two conditions again. So in this case, in both of them, I have to put an if function. Let's say x smaller than 0. Even if it's not smaller than 0, I have another if. Why? Because smaller than 0, I have 2. So I use this one. No need to use this. Now, I'm coming inside the first. Well, if this is true. If x is smaller than 0, I have two more conditions. Let's say I'm using the first one, z smaller than 0. Now I'm going to explain something here. Now if this is true, I will be having x squared plus, I will be having x squared plus z squared. If this is not true, means that z, it's, look, I am still within what? Within x smaller than 0, because this side of the function, or like this is like this, you can divide it to 2. This side is for x smaller than 0. The other side of the if is for x greater than 0 or equal to 0. Now I am still inside x smaller than 0. I don't need to check this one. Why? Because I check z smaller than 0, then this is the false value gonna contain z greater equal to 0. Then here we're gonna write x squared plus root z. Now if the first one it's not true, it's gonna be false, I have another if function. Now the question arises here. Some students say that I wrote z smaller than 0. Remember this if finished here. This if finish. You are inside another if, you have to write the logic. So this time you will write z. I can write z smaller than 0 again. Look, I could use the second one. If I use the second one, I need to use the first one. So I don't need this one, because this, if it is going to come here, else will be here. So I can write it here. This is root, I don't know, root x plus z square. It should be root x. If it is false, will be root. Why? Because both the negatives will be here. The negative value is going to come here. If x is, sorry, the positive value is going to come. If negatives, one negative going to come here. And then this will be the scheme for the solving here. How do we put them inside each other? I need you to have a look at these three conditions here. Now each of them will contain something there. Now let's solve an example to see how we combining those if function inside each other, the practical point of view, or to see how we practically not making any mistake. Yeah, with the with those flowcharts, they were easy to explain, but when it comes to Excel, we have to put all of these things in a function and to see how does it work. By the way, some people, they separated. I will explain this one as well. For those who they don't like nested if, sure, there will be an easy way for them. But I'm gonna explain the professional way, then we're gonna go for the other one. Now it says that we're writing a function. Use the given table. So let's say this is x value, this is y value. Now I'll input something here, and y is supposed to be found. It says that x smaller than 0, x greater than 0, x equal to 5 is equal to 5. So this 3 output I have it, x squared root x 5. We're writing if equal if function. Now they're starting with logic. Which logic you're gonna start is up to you. It's up to you. Remember, 3 of them you're gonna just choose 2. Why? Because if else. It doesn't matter which one. Let's say I'm starting with x equal to 5. You see, if this is equal to 5, I use the last one. The x value will be, the y value will be what? Will be 5. Let me use this one for later. It will confuse you. Let me start with the first one. X smaller than 0. X. Remember logic, 3 part. X smaller than 0. If x is smaller than 0, this is the logic. I'm going to use a separator. Look, as soon as I press separator, I will see value of true became bold. It means that it's active. It's time to write value of true. What do you want to be happen when x is smaller than 0? Remember, this is y equal to this. So I'm going to write the function, which is x squared. X squared. Now, I want to write that one. If x is not smaller than 0, so it's value false, yes, a separator. Remember, your separator may be semicolon. Value false. If the value false, maybe this or this, that's why I need another if. Remember, if x is not smaller than 0, maybe this, maybe that. So we're gonna write another if function. Look, this is value if false. I'm starting with another if function. So if I double click on this if, I'm inside the second if. Starting back from the logical test. Yes, the logic will, let's say that's x greater than 0 this time. If x is greater than 0, then look, please do not close parentheses. Closing parentheses, it's the main problem in the nested if. The main problem or the source of error is parenthesis closing. You close parenthesis when the 3 argument finish. Remember this, please. You close parenthesis when the 3 argument finish. Some student, they close the parenthesis here. They close the parenthesis. This is wrong. Is this if has the 3 argument yet? No. And this will be for who? So remember, do not close the parenthesis until you will finish the 3 argument, then you can close the parenthesis. In that way, you will not make mistake. Now, I'm inside this logical, I wrote it. If x is greater than 0, remember, you are already in the false value of x smaller than 0. You don't need to check again, because it confuses students. They say that, okay, but how do I know x is smaller than 0? Remember, I put that if inside an if that is checking for x smaller than 0. If x is smaller than 0, I have a function. But if x is not smaller than 0, which means that x is greater than 0, or maybe equal to 5, that's why it comes here. It says that if x is greater than 0, if x is greater than 0, we'll be having what? We'll be having, now I'm going to tell you that there will be something wrong, but we'll explain it to you why. xqrt, because it's root x xqrt of x. Then what if this value, what this condition is not true? I have the last one, yes, I have the last one, which is x equal to 5. I don't need to check it. Why? Because I have 2 if that's going to be, so we said that if this is if, this is if, the last one will be, we're going to tell you why it's going to be wrong, why it's going to be wrong. But the way of solving it's okay, but the logic locations will be wrong. Now I don't need to write another if, that will be enough to write the last one, which is equal to 5. Now let's see when I'm closing a parenthesis. This is a logical test, a value if true, a value if false. It's time to close the parenthesis for this if. Now it will take me back to the first if. I have a logic, I have a value if true, and I have value if false. Look, the value if false, you must see the full f supposed to be selected. Why? Because we converted the value if false to another if function. Now if I press enter, directly give me 5. Let me write something here to be minus 3. Minus 3 will be what? Minus 3 smaller than 0 will be minus 3 squared. That's okay. What if it is 6? Yeah, root 6 will be 2.44. 8 is going to be 2. Let's say 4 is going to be 2. If I put 16, because 16 is going to be above, it's going to be, what if I put 5? I get 2.3. I should have got 5. The value of 5 is, when x is 5, y is 5. So it must be constant, but I'm not getting it y. Now I'm going to explain this one with a flowchart. With a flowchart. With a flowchart to see why it's going to be wrong. If you understand from here, if you understood from here, it means that you know the logic, how does it work. But if you haven't understand, if you don't know why this is wrong, I'm going to explain it to you with a flowchart. That's why I'm always recommending students to go for the flowchart to see if the flowchart is working with them or not. Let's say that I'm going to use a flowchart here. So this program is opening. Let's say I'm having an if function, yes, an if function. This is the if. By the way, let's open this one. Let's see, hopefully, okay. Now, in this way I can see the if function to see why I'm having mistake here. Now, there's an if function. It says that if x is smaller than 0, so let's say true to be here. If x is smaller than 0, that's what does it say? We're using x squared. So the output here is x squared. There's not a problem, yes? Then it comes here. Remember, this is the false one, yes? False contain what? False value contain x greater than 0 or equal to 0, yes? Now if you imagine that it's already containing greater equal to 0, yes? By the way, 0 is not included somewhere, but let's say that. Now I used another if. That's, look, the logic, I mean the flowchart is totally fine. The problem you have it is with the logic. I told you the logic is the main key of if function. Even if you know how to put if function inside if function, if you don't know how to arrange the logics, you're not going to get a correct answer. Now, if I knew in the beginning, let's say, by the way, I knew it, but let's say I knew in the beginning that the false of the first if it's already containing values greater than equal to 0. So why would I gonna start with an if function again that I'm saying let's check again to see if x is greater than 0? I already know it's greater than 0, yes? I already know it's greater than 0, so why would I check it again? So you realize that this logic here is wrong. Look, wrong, what does it mean? Not in the point of error, it's not going to give you error. But let's say that y is always giving us error. Okay, this condition here, let me choose a color. Let's choose a different color for the second if. It's the second if. Now if this is true, I'm gonna come here. So if this is true, what we said that it is going to be root x. Now if it is not true, which is false, it must come here. And the false value corresponding to 5. Well, now you realize that the false here contain what? This false here contain what? The value of x is already greater than 0. It comes here. I'm checking in for greater than 0. So the only one, only if x is equal to 0, only if x is equal to 0 is going to come here. Remember, nothing goes into this part unless x is greater than 0. This is when x is greater than 0 or even equal to 0 is going to come here. Then I'm checking in to see if it's x greater than 0. I should have known that it's already greater than 0, so no need to check this one. Now you realize that the only possibility that I will get 5 is only if I put 0 here. So I know that this is wrong. This is wrong. I mean wrong here. How can I manage it? By changing this condition here. This condition is supposed to say that, okay, check if x is equal to 5. If x is equal to 5, then I'm going to put 5 here. If not, I already know it's greater than 0, then that will be the root x. So I have to manage it in this manner. In a way that I have to change this one condition here to be x equal to 5, so that to exclude 5, because I already know that the values are greater than 0. I only need to exclude 5 out of it, then sure this one inside here will be x greater than 0. Except 5, because 5, if it's 5 2 is going to come here, if not, it's going to go here. So if it is not equal to 5, it's going to, let's say write it like this, not equal to 5 is going to come here. This has become so bad. So in that case, the false value here, it's going to say that if x is not equal to 5, if not equal to 5 is going to come here. We already know that it's greater than 0, so it's going to be true. That's how we have to manage it. So I always recommend students, if you don't know to calculate those from your head, I started with this one because I knew it in the beginning. The x5 I started with it because it was easy to start with it, but I said that let me to not to confuse you, but this is a good practice to know that you have to make sure that run before the Excel, run to see if it's working or not. So it means that I'm going to adjust this one. I'm going to say if b4 is equal to 5, then I'm going to say 5. Now let's check. Say if this is true, if y is equal to x is equal to 5, y value will be 5. If not, I'm going to take the root of it. So this way it's working. 5 is equal to 5. If I have minus 3 will be, if I have positive value, 4 is going to be taken as root, 16 is okay, except 5 will be 5. 5 will be 5. Why? Because within the, I use that 5 as a condition for the solving there. Remember, sometimes happens things like this. You have to be careful that your logics, the flow of your logic covers all the possibilities. You may not get any error from Excel because Excel works, and that's the main problem with using program for your calculation. They don't know if it is wrong or right. They don't know it. You have to check by yourself to see if it is right or wrong. then this will be the solution for this question that we have it here. I believe that, I didn't, oh, this is the old version. I will change this one. I'll change this one for the way that we have it. Now, another example we have it here. Another example we have it here. This is 4 outputs. We're using 3if function. I'm just gonna go through it for the final solution. Final solution for this one. Because this is something very simple. Very simple. Then I have something else. I'm gonna spend one video which is related to civil engineering. Now let's check if this one. If x is equal to 50, x plus 5. If x is equal to 60, x plus 6. If x equal to 70, x plus 7. The last one will be not defined. Now, parenthesis closing. Parenthesis closing. Look, how many parentheses opened? 1, 2, 3 parentheses opened, 3 parentheses must be closed. But remember, checking before closing them. 1, 2, 3 output, I'm closing 1 parenthesis for this if. Checking the second if, I have 1, 2, and this is completely, so if this is 1, if this is 1, this is 2, this is a complete for the third argument for the second if, so I'm closing the second if parenthesis. Checking for the first if parenthesis. For the first if, do I have 3 arguments? 1, 2, and this is completely will be 1 argument, then I'm closing the if functions there. By the way, the question was what? The question is saying that if x is equal to 50, this is the function. If x is equal to 60, this is it. If x is equal to 70, this is it. If not, it's not defined. Otherwise, this is, if you think of it, it's nothing logic. I mean that it does not make sense, but it's just an idea to see how to use 3 ifs inside each other. Now you realize that what happens here. Let me just draw the flowchart for this one as well. The flowchart of this one. Because it's coming if after if, I'm going to explain it in this manner. So let's see if I can. So let's see. Basic diagram. Okay. Let's say I'm having an if function here, an if function here. So if this if function we'll say that if x is equal to 50, this is the function, the condition I have it there. Condition I have it there. Big, just to see them. Now, if x is greater than 50, what we will do? So we have two conditions. There will be two conditions. I have it. One will be if true, one will be if false. Now remember, any if that you're writing it, I recommend you to go with the flowchart. So this flowcharting will help you later. If x is greater than 0, so basically I'll be having an output. Let's say this side, we're changing it for the output. So if x is greater than 0, y will be equal to, I don't know, was it x plus 50? Always will be 55. Will be 55, but let's say this is the condition we have it here. This is the condition we have it here. So in this manner, if you're able to do your calc or flow chart, you will understand what will happen. Now, if x is not equal to 50, I have another if. So that if will be placed where? When it's false. Remember, this is true, this is true, and this is when if it's false. This is going to be for the case of false. Now, if it's true, I have a function. If it's false, I have another condition, which is another if. I'm checking it for 60. Again, if this is true, I have this time the value will be x, maybe another function, whatever it is. It's just simple function, I wrote it. But again, if this is not true, what do I have? I have another if function. There will be another if function coming here. So that's why you realize that it's going to be if inside if. So if it is false, by the way, you can do this one on a paper. Believe me, if you know how to make the flowchart, the rest will be easy writing it, because now you know that the false value is going to come here. Now if it's false this time, I'm checking for 70. If this is 70, I'm going to having another equation. So finally when reached to now remember what I'm doing. I'm saying that if x is equal to 50, this is it. If x equal to 60, this is it. If x equal to 70, this is it. Else will be not defined. So for the not defined, to the last part, not defined, I don't need to put another if function, because if it is not equal to 50, not 60, not 70, it already will be everything, and everything will be not defined there. So this is going to be the last one, and that one will be not defined. So this will be the output not defined. Now you realize that we use 3if function in this manner. We change the false. So why do I need to explain this one? When it comes to closing parenthesis, so I'm always saying that, telling my student, if you know how to draw the flowchart, you know how to do the if function. Why? You're starting with this if, yes? Starting with this if. If this if true, where do you start? Let me just make it as a number sequence. For the sequence to see which one start as a numbering to see which one start first. Now, this is going to be, the if will be 1, yes? The logic will be 2. Then, we're writing x plus 5, 3. Then where do we go? We go to the false. False, here we have another if. So I'm writing an if. For this if, I have to write the logic of it. Look, I'm inside here. This will be 5th. Then I'm going to come here. I have to write this one. Look, I haven't finished this part, yes. I haven't even finished this one. I'm going to go for false of it. The false of it, again, another if. So I have to start with another if, then the logic of the if, then the true of the if, then I'm going to go for the false of the if. Now, this if finished here, yes. So the parenthesis will be closed. The parenthesis, when it opens here, closes after writing the false value. If this is already the false for this one, yes. So this, let's use different color. The parenthesis that you opened it here for this if will be closed even here. Why? Because this is all of it, it's a false value for the second if. The first if, when you open the parenthesis in the beginning, let's say I'm using different color, you open the parenthesis here, this is the true, and all of this is the false. When you finish it here, then you're going to close the last parenthesis here. Remember, parenthesis clothing, it's very important. You have to make sure that everything is in a location, then you'll be able to finish the parenthesis gradually. And this is, I need you to do two things, please. If you want to know, if you want to be able to answer any type of if function question, try to be able to do flowchart like this. this flowchart, then converting flowchart to an Excel or from Excel to flowchart, it's something useful from the beginners, not from this one. I needed to do this one in the beginning with the last videos that we explained them, the previous video. When there is only one if, I need to start from there. Then when it comes here, when we're replacing one if, remember what I'm doing, this one, all of it, all of this with the if, everything, this is replacing who? Replacing a value when is, if this is not true, because I don't have anything to put it here. Why? Because I don't have anything here. Why? Because I have to check others. Instead of this one, we're going to put this if inside here, and you know that this was something and I put another if inside. That's why we're replacing this one, which is the value false, by another if, then the value false of that one by another if. Believe me, this is can be done for as many ifs if you have it to do it in this way. But this is still simple. This is still simple. This is still simple. So I will leave this one for you to do it. But this is an example of civil engineering to see how hard things gonna get. And this is still a small part of it. Then I'm gonna make a video of it. The second video that will come, I believe, for this week. It needs a lot of explanation. I'm gonna finish this one. Will be some more example coming, because now we have a lot of ideas. We can give you a lot of examples and you'll be understanding them easier for the purpose of calculation. We have it. Thanks for watching.